Cool. So we have two sets of questions, and the first set of question reads, we are required to simplify the logs. The first log, we have log base 3, log base 8, log 16 base 2, which is the first set. And the second set again, we are given log base 8, log base 4, log 64 base 2. So these are the two sets given. And if we consider the second part of the question again, we have if a squared plus b squared give us 7ab, right? A squared plus b squared give us 7ab. So we are required to show or to prove that, or in whatever way, this left-hand side result must be equal to the right-hand side result. So the left-hand side result reads log 1/3 into a plus b equals to half bracket of log a plus log b. So we are required to simplify the first part of the question for 1, and the second part we are required to show that the left-hand side result must be equal to the right-hand side result. We are going to play with this value to give us this. So the two sets of questions are simple and as well as straightforward. With regards, we must have to have the basic. We must have to have the basic, and the basic of solving these two problems. For the first part, we can see this log, we are not given any number here. Subsequently, the second log again as well, and the last log, we are given the log of the number and as well as the base. So this must tell you that you start working these type of problems at any time you come across them from the extreme end of the log which is given, or the log that is provided where the log of that number is given and as well as the base of that number is given. Looking at the end log given, the last log given, the log of the number and as well as its base, both of those numbers are well provided. Those numbers are given, the base is given as well as the number is given. So as well as the second part again, the b part, we are only given the base for the first log, the base for the second log, but the last log, both the number and the log we are given. So you see, so when you come across these problems, you start working them from the last log. So in this case, we start to work with this log. The answer we are going to have for log 16 base 2, we are going to plug it here. So work again this second log, the results we are going to have, we plug it here. So finally you work the last log. So it means you move forward, starting from the extreme end, and you move backward for you to have a result. So in this case, if we start solving these problems, we take the first part, right? If we take the first part, A says log base 3, log base 8, and log 16 base 2. So we are given log 3, log of base 3, log of base 5, and log of 16 base 2. So I hope this is clear. So since we are given these numbers, let me just drop them down. Log base of 3, log base 8, and the last one log 16 base 2. So we are required to simplify. So as I said, we start from the extreme value. We rewrite the first two log base 3, log base 8, and log 2. And this number, anytime you work with logs, I think one of the bases will be you try to make the base of those logs to be the same. If you look carefully at this log, the two numbers given, both the base and the number given, we can see we can have a way of making the base of that log to be the same as the number of the log. So this 16 will find a way of making it to have the same base as this. So 16 is an index form which can be repeatedly multiplied in different sets of numbers, either by 4 by 4 or using 2 by 2 by 2 by 2. You see, so in index form, this can be written as 2 raised to the power 1, 2, 3, 4. Or for this one, this can be written as 4 raised to the power 1, 2. So 16 is either equivalent to 4 raised to the power 2 if you want to use 4, or equivalent to 2 raised to the power 4 if you choose using 2. But for this case, since the base given here is 2, so we select 2 raised to the power 4. So choosing this value, which is 2 raised to the power 4. You see? So if we move forward, this 4, we can move it to the coefficient of this log, which will be written as log base 3, log base 8, and this remain as 4, and log 2 base 2. You know, log 2 base 2 is what? Is 1. You see? So since it is 1, so there is no need for us to write it again. We can just remove this. So the 3 logs, when simplified, we finally have 2 logs. So in the same sense, we are going to work these 2 logs, this log again, to only give us only a single log, and we'll take again this last log to give us a single number. So if we work with this, we rewrite this log 3, and 8 can be written as 2 raised to the power 3, and 4 can be written as 2 raised to the power 2. So which can as well be written as log base of 3. When these 2 moves, we have 2 upon, when this 3 moves again, upon 3, and we have log 2 base 2. You know as well again, log 2 base 2 is 1. So therefore, the final result from this set is going to be 2 divided by 3, because log 2 base 2 here will just be 1. You can stop here. But further, if you want to simplify it, since you are dividing logs, you can take the base to be the same. And since we are dividing, you subtract the numbers given. So you're going to be log the numerator of the number minus log the denominator of the number, which is 3. So in this case, we maintain log base log 2 base 3, and log of the same is 1. So therefore, the final answer will be log 2 base 3 minus 1, because log 3 base 3 is the same. The log of a number to its base is always 1. So this is the final answer for this law. So the first part, the answer is log 2 base 3 minus 1. That's the result. So this is the end of the first part. So if we move to the second part again is almost the same steps. We are going to follow the same steps, which is log base 8, log base 4, log of 64, base 2. Yeah. So let me just clean the first part. So if I choose like rewriting the second part of the question, log base 8, log base 4, and log base 64 base 2. You see, we have log base 8, this is 8, log base 4, log base 64 base 2. Yeah. Log 64 base 2. So if we are to solve this solution, so the same steps as described from the A part, we maintain the log of the first as well as the second, and we simplify the last log. Base 2, 64 is the same as 2 raised to the power 6. In this case, this 6 will move to the coefficient of 8 log. So we have log base 8, log 4, and this will be 6 log 2 base 2. You see, we know log 2 base 2 is what? It's 1, so it's just going to be the same, so we remove it. Yeah, so now these 3 logs remains 2, log base 8, log 6 base 4. We'll further simplify these 2 values. So maintain the first log, we write it, and this 4 is same as 2 raised to the power 2, and this second again is 2 times, or we can just maintain it as 4, or let's just write as 2 raised to the power 2, and this 6 is same as 2 times 3, or let's leave it as 6. So if we move this 2, it's going to be log 8. And when this 2 moves, it's going to be half log 6 base 2. You see? So, but this, we can separate them. The base is the same. Now we have two numbers, this half by this number. So we can say, because if you have like log AB base k, this is the same as log A base k plus log B base k. It's the same thing. This log base 8 will be this plus this. So this is log of half base 8 plus log of 8 to this number, which is log 6 base 2. This part is very, very, very critical. So we need to take note of that. Yeah. So if we continue, we take log, but this 8, this half is same as 2 raised to power minus 1, right? This half is the same as 2 raised to power minus 1, this log, this number. So say log 2 raised to power minus 1, and this 8 is same as 2 raised to power 3. We take our plus sign, and the base is 8, 2 raised to power 3. And this log again, we can say log. This 6, we can simplify it as 2 times 3. I think this is it. So if we move carefully, this negative will move, going to be negative 1. And this 3, when it moves, going to be a fraction. So we have log 2 base 2. So if we move plus, when this 3 moves, going to be a fraction, 1 upon 3 log, and it remains the base. And we have log. This again, since we are multiplying 2 log, we can separate this single log, this log given. We can separate it, because if you have log 2, because if you have log 2 times 3, same as log 2 to the base plus log 3 to the base. So we separate this log. So if we separate that log, 2 times is going to be log 2, and its base was 2 here. We should not forget the base, plus log 3, and having the same base as 2. So carefully, this is what we have. So if we integrate, we move step, log 2 base 2 is just 1, so this is going to 1 upon 3 plus 1 upon 3 log base 2. Here log 2 base 2 is 1 plus we have our log 3 base 2. This is this. Yeah. So let's look at, we simplify, we are required to simplify. 1/3 is common, 1/3 is common. We can factorize it. You see 1/3 factored, and this will be minus 1. Plus, if 1/3 is removed, so we have log base 2 into 1 plus log 3 base 2. You see, so in this case, since we have a negative sign here, we can, normally when a negative sign stands in front of a number, we don't want to see short, so we can decide by writing this number first, followed by this negative sign. So this will be, we start writing this log base 2, and we have log base 3 base 2 plus 1. So we have this number to be this. We have this negative sign, negative 1, divided by 1 upon 3 can be written as the whole value divided by 3. So this is the end of the second part of the question. So you see how simple and straightforward. You see, because we must have confidence in resolving these problems. So this is it. So if we consider the second part says if a square plus b square give us 7ab, we are required to show that the left-hand side will be equal to the right-hand side. But the technique we are going to use here, consider 7. How can we make 7 to be equal to 3? Because the logic is, we find ways of having this value to be equivalent to this. Since we have here 2, we also find, since there's a square here, it implies we are going to factorize this, which is going to give us a quadratic, because this is a quadratic term, this is a quadratic term. It means we need to have another third term that we are going to add here. So we are going to factorize that term. If we factorize the quadratic term, it means the degree is going to be 2. So that 2 will be related to this half here, these two. Same way, we find a way to work this, which is going to give us something which will be equivalent to this. So in sense, if we add 2 here, this is going to be 9. So 9 can be written as 3 squared because 9 can be written as an index form because 9 is same as 3 squared. So that 3 squared will have to do with this 3. So I think this is just the basic we have to capture. So let's take the second part of the question. So if we take the second part of the question, we are given a squared plus b squared to give us 7ab. So how can we have 9 here? Simply we add 2 and we also have 2. What we do on the left, we should also do it on the right. So this will be a squared plus 2ab plus b squared give us 7ab plus 2ab. I think this is the procedure, one of the procedures. So if we factorize this, when we factorize a squared plus 2ab plus b squared, we have a plus b all squared equals to 7ab plus 2ab. This is going to give us 9ab. This is it. So, mind you, don't forget this a squared, we can simplify, this 2ab can be split as ab plus b squared. You group these two terms, you also group these two terms. So when these two terms are grouped, we have a into a plus b, plus when these two terms are grouped, you have b into a plus b. We take this a and this b, so we have a plus b in a bracket, and this again a plus b in a bracket. You find out that they are the same. You can take one bracket, a plus b, and the degree, since there are two, the degree is going to serve as how the numbers are repeated. So this is it. So in this case, to have this 3, we divide by 9, divide by 9. So doing that, we say divide by 9 here, divide by 9. So this 9, carefully cancel this 9. So this will be a plus b. 9 can be written as 3 square. But since there is a square here, I will just say the square is affecting both equals to ab. Because 3 square same as 9 and a plus b square same as this. So in this case, we introduce log on both sides. If we introduce log here on this left hand side, we introduce log on the right hand side. So the value will be log into a plus b all over 3 all squared equals to log ab. You see? So if we carefully move forward to complete this problem, so this 2, we move it to the coefficient of this, which will be 2 log into 1 upon 3 into a plus b, because this 1 upon 3 same as this, equals to log a b. Yeah, I hope, yeah. So if we move here to have this half, it means we are going to divide, because if you look at this question, that is, we have a number here which is 2, so we have to remove it here for it to remain, for the coefficient here to be 1, and that number, if we divide it here, is going to be half. So we divide here both sides by 2, here also both sides by 2, so 2 carefully cancel 2, so the log remains log of, it means log of 1.3 into a plus b equals to this 2 is same as half log ab. So finally we have log 1 upon 3 into a plus b. This will be half into, when you multiply two logs of different numbers, you take one of them and you add each of the values. So you're going to be log of the base, which is a, plus log of the base, which is b. So carefully, this is how we show that the left hand side is equals to the right hand side. Thank you, but this will not be the end. I will give you 2 questions to try. So let me just write the 2 questions you will try, and I hope so. The same thing, simplify the A part. Let's say we have the A part, we have log 4, log 2, and log 81 base 3. And when you simplify, the answer must be half. You also try the B part given as 3 raised to power 1 plus log 4 base 3 plus 2 raised to power log 3 base 2 minus 2. So these are the 2 problems I want you to try. But let me just guide you for the second part. If a little guide is given for the second part, so you will try, go at all costs to complete it. So this second part, let's just take this second part. So we take 3, this one, constantly log 2 base 2, log 10 base 10, log 5 base 5, all equals to 1. So this one we'll write it in terms of log to be the same as this, which is log 3 base 3 plus log 4 base 3. This is the first step you must take. So moving forward, 2 raised to power log 3 base 2, and this 2, its equivalent is going to be log, since the base here is 2, it's going to be 2, it's going to be 2 square. So you combine this, you have log 3, the same base, 3 times 4, 12, plus 2, log 2 is the same, 2 square is 4, it's going to be 3 over 4. So at the end of the day, you can see 3 is the same, the answer is 12, plus this and this is the same, so the answer is 3 upon 4. So when you add this, you must have something like the answer for this one must be